Hello everyone, today we would like to talk about relative error and percentage error. These two errors are used to compare the accuracy of the measured values. In the previous video, we talked about errors during measurement, and depending on the measurement tool, that gives us the maximum absolute error. Let us quickly revise on the definition of the maximum absolute error. Here are three measurement tools. In order to find the maximum absolute error, we would first need to find the scale interval of each measuring tool. Scale interval meaning what is the smallest unit on each measuring device. And the maximum absolute error is defined as half of the scale interval. First get the scale interval, then divide it by 2 to get the maximum absolute error. The device on the left, the scale interval is 1 degree, so the maximum absolute error is 0.5 degrees. The middle one divided by 2 is 2.5 millimeters, and on the right, 1 second divided by 2 is 0.5 seconds. So that was a quick revision on what is the maximum absolute error. So after that, it is very easy to find out what is the relative error, which is defined as the maximum absolute error divided by the measured value. The relative error sees the relationship of the error to the measured value, and this is expressed as a fraction. Since it is expressed as a fraction, there is no unit for the relative error. Here's a very quick example. Here are two of the same pens. These two rulers with different scale intervals measure the same value. Both are measured as 7 centimeters. But since the scale interval of these two rulers are different, so the maximum absolute errors are different, therefore the relative errors are also different. So for the top one, the scale interval is 0.1 centimeters, which means it gives a maximum absolute error of 0.05. And for the bottom one, it's 1 centimeter as a scale interval, giving the maximum absolute error of 0.5 centimeters. Using the definition defined before, the relative error is the maximum absolute error over the measured value. On the left-hand side is 0.05 divided by 7. On the right-hand side is 0.5 divided by 7. Once you have the numbers, all you need to do is plug it into the calculator, and here you get these two values. These two values just need to press the upper left button on the calculator, and that will turn it from a decimal into a fraction. So then you can express the relative error in the form of a fraction. Seeing it in fraction form, you can also see that the relative error on the right is much bigger than the relative error on the left. It is as much as 10 times the difference in the relative error. Lastly, what is the percentage error? It is quite simple. It is defined as the relative error learned just now times 100%. We have learned before that turning fractions into percentages is as simple as multiplying by 100%. Using a percentage to represent the error is much more easier to read than expressing it as a fraction compared to the relative errors. Let's say we were given the relative error of 1 over 7. Using the calculator, we can easily calculate the percentage error by multiplying it by 100. Make sure you do not put the percentage inside a calculator as it's just a unit. Multiplying it by 100, we get 14 and 2 over 7. Percent is the unit, so it's kept. So we can always press the upper left button and we can turn this fraction into a decimal, giving us 14.28%. Sometimes this gives us a never-ending decimal, therefore we need to round it down. If it's not specified, we can just correct it to the nearest third significant figure. Let us try out some examples so that we can better remember what we have just learned. This example says that the time taken to run around a park is 80.4 seconds, corrected to the 0.2 second. First, we need to find the maximum absolute error. Remember that the definition of the maximum absolute error is equal to the scale interval divided by 2. And here we can see it's corrected to the nearest 0.2 second. Therefore, we can deduce that the scale interval is 0.2. So we plug it into the equation. The maximum absolute error is simply the scale interval, which is 0.2 seconds, divided by 2, and that's a maximum absolute error of 0.1 second. Now, the relative error is defined as the maximum absolute error over the measured value, which is 0.1 over 80.4. Measuring as a fraction using our calculator, we can see that is 1 over 804. For the next question, we can see the height of a pole is 13 meters high, corrected to the nearest meter. So now we're finding the maximum absolute error. Again, first we find a scale interval. Looking at the question, it's corrected to the nearest meter. So the scale interval is 1 meter. If the question just has a letter M, like here, meter, we can always think that there is a hidden 1. So the scale interval is 1 meter. The maximum absolute error is defined as the scale interval divided by 2. So 1 meter divided by 2 gives us the maximum absolute error of 0.5 meters. And now the relative error is defined as the maximum absolute error over the measured value, which is 0.5 over 13, giving us 1 over 26 in fraction form. The next question, the length of a string is 3.2 centimeters, corrected to the first decimal place. Now, again, to find the maximum absolute error, we first need to find the scale interval. However, here, the scale interval is not directly shown. We can see it's correct to the first decimal place. What does the first decimal place mean? It means this 0.2, this 10th spot. So what is the smallest value of a 10th spot? It's actually 0.1 centimeters. That is what 1 decimal place means. So now that we have the scale interval divided by 2, we get the maximum absolute error of 0.05. The percentage error we have learned a while ago is just the relative error times 100%. So first we find the relative error, which is 0.05, the maximum absolute error over the measured value, 3.2. Now we times 100% to get the percentage error, 1.5625%. Remember, we only times 100, not the percentage. The next question, the weight of a tiger is 250 kilograms, corrected to 2 significant figures. Again, for the maximum absolute error, we first find the scale interval. And the only thing we know is that it's corrected to 2 significant figures. So what is 2 significant figures? So as you can see, it's 250 kilograms, and 2 significant figures is the first 2 numbers here, and not counting the 0. Since we're not counting the 0 at the back, the most accurate you can ever get is really by 10 kilograms. So therefore the scale interval is defined as 10 kilograms. So that's kind of a trick that we need to do when we're looking for the scale interval when we're only given the significant figure. Dividing it by 2, we get 5 kilograms as the maximum absolute error. Percentage error is just the relative error times 100%, and the relative error is the maximum absolute error 5 divided by the measured value 250 times 100%. Using the calculator, you can find that the percentage error is just 2%. So that is all that we're going to teach for you today. If you have any questions, feel free to ask your teachers or go to the math room. Goodbye.